Redraw the circuit of question 1 putting in an ammeter to measure the current through the resistors and voltmeter to measure potential difference across 12 ohm resistor. What would be the readings in the ammeter and voltmeter? This is the first question. 3 resistors 5 ohm, 8 ohm and 12 ohm. These 3 are connected in series. And a battery of 3 cells, each of EMF is 12 volt. These 3 are connected in series. So total EMF of the circuit becomes to 6 volt. So in this circuit we have to modify to connect an ammeter and voltmeter. Ammeter is used to measure the total current in the circuit and voltmeter is used to measure the potential difference across only 12 ohm resistor. These 3 resistors are connected in series. First cell, second cell and third cell. This is positive terminal and this one negative terminal. 6 volt. We want to connect an ammeter to measure the total current in the circuit. Either ammeter is connected left side of the battery or maybe the right side of the battery, no problem, it gives the correct reading only. When we take the position of ammeter right side of the battery, this is the symbol of ammeter. Ammeter has 2 leads, that means 2 wires. One is positive, second one is negative. Actually, these 2 leads represent how to connect the ammeter in the circuit. Okay. So positive terminal of the ammeter always connected to the positive terminal of the battery. And negative lead is connected to the negative terminal of the battery. So this is plus sign and this is negative sign. Just these are symbols how to connect the ammeter in the circuit. Remember this. Positive lead of the ammeter is connected to the positive terminal of the battery and negative is connected to the negative. Maybe when you connect the ammeter at this point, then negative sign of the ammeter is connected to the negative side of the battery. Remember this. So ammeter connection completed. Remember this point also, ammeter is always connected in series. Next we have to connect voltmeter to measure the potential difference across the 12 ohm resistor. Voltmeter is always connected in parallel. This is the symbol of voltmeter. This is plus and this is minus. This is the connection of the voltmeter. And also in this circuit a plug key is there. This is the symbol of plug key. When the circuit is open, when we close the circuit, put dot. The battery of EMF 6 volt. Ammeter, 3 resistors are connected in series and a voltmeter across 12 ohm resistor is connected in parallel and this is a plug key. So this is the required schematic diagram. Now by using this diagram we have to find out the total current in the circuit. To measure the total current in the circuit, first find out the equivalent resistance of the circuit. All 3 resistors are connected in series. Equivalent resistance is equals to sum of the resistances of the resistors. R1 plus R2 plus R3. R1 is 5 ohm, R2 8 ohm and R3 is 12 ohm. Equivalent resistance of the circuit is equals to 25 ohms. Now take Ohm's law. V is equals to IR, where R is equivalent resistance of the circuit. I is equals to V by R. Potential difference of the battery is 6 volt and resistance is 25. 0.24 amperes. This is the current passing through the circuit. Now we have to calculate the potential difference across the 12 ohm resistor. Actually in series connection potential divides. The potential at 5 ohm resistor V1, V2, V3. But in series connection electric current is constant. How much current is passing through the 5 ohm resistor? The same current is passing through 8 ohm resistor and also 12 ohm resistor. So I is constant. The formula to calculate the potential difference across the 12 ohm resistor, V3 is equals to IR3. Electric current is 0.24 and R3 is 12. Now multiply this. 2.88 volt. This is the potential difference across the 12 ohm resistor.